Welcome to video 21, 4.2 area, part 1. Today we're going to look at finding the area under a curve, estimating the area, using rectangles, and talking about summation. So this first example, we're given our curve f of x equals 20 minus x squared. We want to estimate the area between the graph and the x-axis, between x equals 1 and x equals 4. We want to create 6 rectangles where the right endpoint is on our curve. So with that said, I want to first draw my diagram. So if I have 6 rectangles between 1 and 4, I have to kind of divvy that up so that they are equal increments, okay? And my right endpoints need to be on my curve. Since our interval is 3 units long and I have to divide this into 6 equal increments, I know my x's or my delta x is going to be 1/2. So each right endpoint is going to be 1/2 units away from each other. So I know I'm going to put my first right endpoint here, and I go ahead and I draw my rectangle. My next right endpoint is going to be at x equals 2, and then I go ahead and draw my rectangle, so on and so forth. So you should see our right endpoints of each rectangle are on the curve. I want you to copy down this table, so if you need to, go ahead and pause the video a second, and then I'm going to walk you through it. So we have 6 rectangles, and what I labeled here are the right, or the intervals of those x's. So this first rectangle goes from 1 to 1.5. The right endpoint is when x is at 1.5. So our second rectangle is on this interval. The right x value is 2. And you can see that for each of the rectangles on down. Now, if we're thinking about the area under this curve using rectangles, we know that it's base times height. Okay, so the height of each of these rectangles is going to be that f of xr, meaning the f of the right x value. So I'm going to plug that into our curve that we were given to. So f of x equals 20 minus x squared. I'm just plugging the right endpoint into this function, and that's where we get those y values essentially. So that's the height of each of the 6 rectangles using my right endpoint. Okay, so one thing to kind of think about as we're doing our labeling is when you see x sub r, that means the x value of our right endpoint. Okay, so in this case, it starts with that a value, the start of our interval when x equals 1, and we simply add delta x sub I. I is just going to be which rectangle we are on, okay? So this is 1 plus delta x from that first rectangle, and then we would keep going, okay? So our interval in a nutshell, generally speaking, if we're on a to b, delta x is going to be b minus a, our interval, over n, where n is the number of rectangles. So here we had 4 minus 1, which is 3, over 6. So because we had 6 rectangles, so our delta x was 0.5, which you can see that's what our right endpoints are going up by. X sub r is the a value of our interval, plus delta x times I, where I is the rectangle number, and x sub r is the right x value of that endpoint. Okay, now we're going to get into our summation notation to figure out, well, what is the actual area under the curve using those rectangles and right endpoints. So as we mentioned, we're adding up, that's what this summation represents. We're adding up the area of each of these rectangles, in our case 6 rectangles. Each rectangle to find the area is base times height. In our case, the base is our x's, which is our delta x, right? If we look over here, the base is the length of that delta x. The height is that f of that right x value for our right endpoint, okay? So this is our base, This f of xr is our height, okay? And now we're just going to plug in using the fact that rectangles is base times height. So that first rectangle, our base is 0.5. The height that we found in our table is 17.75. Our next rectangle, rectangle 2, our base is 0.5 again. Height is 16. Third rectangle, 0.5, height is 13.75, so on and so forth. When we add up all these areas, we would get the total area of the right endpoints is 35.125. Now notice I have this note here that this is an underestimate. Take a look at our graph. We can say that this is an underestimate or a lower sum because our rectangles don't meet the curve exactly. There's little pieces here under the curve that we're not taking into account. So we can say that this sum is an underestimate or a lower sum. Okay, what if we shift now to 6 rectangles, but we want to use the left endpoints? Notice now my first rectangle is still between 1 and 1.5, but now my left endpoint meets my curve. So I go and draw my rectangle, and now my second rectangle, the left endpoint meets my curve, so on and so forth. So now if we were looking and coming up with the area here, we could go ahead and say, just like before, each area of the rectangle is base times height. The base is still that 0.5, that hasn't changed. The height, now I'm just looking at the left endpoints. So when x is 1, I would get 19 to be that height. And now I can use the chart from before, okay, where my base is 0.5 and the height this time is 17.5, so on and so forth. Now we get the area of the left endpoints to be 42.625. Notice now how I've noted that this is an overestimate or an upper sum. So if you take a look at the curve, you should see now that we've got extra areas that we're taking into account. So we can see that this is going to be an overestimate because there's more of a rectangle above our curve. One last thing to note is now using that left endpoint, we have x sub L. And this is simply 1, or A, plus delta x times I minus 1, where I is the rectangle number, okay? In summary, the area under the curve of f of x on our interval a to b using n rectangles is this right here, the summation from I equals 1 to n, delta x, that's our base, times our height, f of xi. Delta x is b minus a over n. I is the rectangle number. N is the number of rectangles in total. X sub I can be either xr or xl, depending if we want right endpoints or left endpoints, and we have these here. Another thing we should note is that the area of the lower sum is going to be less than the actual area, which is going to be less than the area of the upper sum. Okay, to find the actual sum, we would use the limit. Okay, so the limit as n, the number of rectangles, goes to infinity. So meaning we want the delta x to be super duper duper small, okay, and we would just take the limit of this summation. This next chart kind of just gives us a summary of the over or under estimates. If we take a look at a function that's going to be increasing, and we draw right endpoints for rectangles and left endpoints, what we should notice is when our f is increasing and we're using right endpoints, this is going to be an overestimate. Okay, now if we're using left endpoints of an increasing function, we should notice that this is going to be an underestimate. Now, if we switch to decreasing using right endpoints, is this going to be an overestimate or an underestimate? Hopefully, you're able to say that this is going to be an underestimate. And then when we're decreasing using the left endpoints, you should notice that we are going to be an overestimate. Okay, so there's something to keep in mind. Now, what if we use inscribed and circumscribed rectangles? Okay, so if we look here, these are all inscribed rectangles, and I apologize that it's a little blurry, but you can get the idea. So inscribed rectangles, you should see that this will be an area, the actual area is less than the total area. This is an underestimate. If we're using these rectangles here, where kind of my center point is where my rectangle touches, it kind of looks like we have a little bit of an underestimate from this portion, but an overestimate here, so it almost seems like it works out. And you can kind of see how that might work in, this guy is going to be a circumscribed rectangles, is going to be greater than the region. So this is going to be like the actual area here. This is the best way to look at it. And the goal would be to get the xi minus 1 and the xi so close to each other that we call it this ci, okay? Where that would be our goal, and we'll get into that later on. This next example, we want to bound the area of the shaded region by approximating the upper and lower sums using rectangles of width 1. So what I want you to do is I want you to draw rectangles that would represent the lower sum. Then draw rectangles that would represent the upper sum, and then we'll compare. Okay, so if you're drawing rectangles to represent a lower sum, you should see my blue rectangles here, okay? And it's not necessarily left endpoints or right endpoints. I'm simply drawing this so that they are under my curve. And so you can see those here. So this happens to be a left endpoint, this first one happens to be a right endpoint, and this last one ends up being a left endpoint. So if we wanted to find the lower sum, I would simply take the area of this rectangle plus this rectangle plus this rectangle. So our delta x is 1, the height is 2, this delta x is still 1, the height is still 2, and this delta x is 1, and the height is 3. So our lower estimate, you should get to be 7 if we look over here. Now our upper estimate, you should notice these are our green. I added some green expansions to the blue rectangles. Okay, so our upper rectangles, now we're using the left endpoint of our first rectangle, a right endpoint of the second rectangle, and a right endpoint of our third rectangle. So now I want to find the area of this rectangle plus this rectangle plus this third rectangle. So 1 times 3 plus 1 times 3 plus 1 times 6. So our upper estimate is going to be 12. So we should know that the actual area is going to be somewhere between 7 and 12. The last thing we need to do is get some practice with summation. The first thing we'll do is just remind ourselves, how do we evaluate a summation summation formula? So if I have the summation from k equals 1 to 4 of this function, how do we evaluate that? Well, remember, I start by plugging k equals 1 in, and then I add all the way up to when I add or plug k equals 4 in. Okay, so what you should see when k equals 1, we get these values, plus, now I'm going to plug when k is 2, plus when k is 3, plus when k is 4, and what we get in the end is a summation of 6. Don't worry about this example for now. You can certainly evaluate that by hand, but we'll come back to it later on. Now we're going to get some practice actually writing in sigma or summation notation. So if we were to look at this first these first terms here, okay, of this summation, what I look at is what's the same and what's different. I should notice that each term has a 9. So in my summation, my numerator is going to be a 9. I also notice that I have a 1 plus in each of my terms in the denominator. So my denominator is going to have a 1 plus. But what's changing? Well, it's the second value in my denominator, and I notice it's going up by 1 all the way until I get to 14. So I know I'm going to be changing that aspect. That number there is where I will call it I. And I notice that I starts when I is 1, and it ends at 14. So I make that note. And there we have our summation notation. The summation from I equals 1 to 14 of 9 over 1 plus I. Go ahead and give B a try on your own. Come back and check. Okay, did you get what I got? What you should have noticed is that every term has this 2 over n. So I needed to include that in my summation. Then what do they have that's similar? Well, they all have this 2 over n, but that's changing a little bit, right? So I know I have a 2 over n to the third power, right? That stays the same. We're subtracting a 2 over n, but that is also changing. So what we should notice is we go from I equals 1 to n, the summation of this, of 2n times this quantity here. Let's try C on your own as well and see what you come up with. So I got the summation from I equals 1 to 7. Now I noticed my signs were changing, so I needed to take that into account. Negative 1 times I minus 1. Why did I do I minus 1? Because my first term is positive. I noticed that 2 is 2 to the first, 4 is 2 squared, 8 2 cubed, all the way up to 2 to the 7th. So that allowed me to say, oh, I goes from 1 to 7. Of negative 1, I to the I minus 1, that takes account the sign change. And then everything is 1 over 2 to the I power. Hopefully you were able to get this. If you have questions on any of this video, let me know next time we see each other.